once again, you can all play Battleship, right? Let the record show everyone in the class said they could play Battleship. Okay, let's go. The coordinate grid is what we call it nowadays, because we don't like giving credit to people who invented stuff unless they were not European. It's become very sexy not to name things after European people anymore, because everything is named after a European person. The coordinate grid is also called the Cartesian plane, because it was named after a French guy, René Descartes. Okay? It is very simple to deal with. It is based on this notation. Number, comma, number. And those are usually written in brackets. Okay? On a pure grid, all right? On a grid that is only talking about numbers, so there's no information about it, you're just counting, we write these as X and Y. Now you guys are smart kids. Look over here. There's an X, there's a Y. Right? They go in different directions. That's what I mean by Battleship. X tells us left, which is positive, or, I lie, left, which is negative, or right, which is positive. Y tells us up, down, which is negative, or up, which is positive. Okay? And both of those are counted from that point right there, which is called the origin, because it's where we start counting from. Is everybody cool? Okay? Now, please notice the order with which these have been written. X is first, then Y's, which means you start at the middle, and then you do your left and rights first, and then you do your ups and downs. Okay? So, to put this in regular English, we go to the X, okay? From there, we go to the Y. All right? So, when you are using these, you have to remember, you go left to right from 0 first. Then up and down from your X value. Does everyone understand? Now, how does this work like Battleship? You have all played Battleship. A6. You go out to A and then down to 6. Right? So in this, it's out to whatever number you want, and then up or down to whatever number you want. Everybody cool? Yeah. Okay, let's see if you really get it. I'm sorry, Tasha. That's okay. On this grid here are 3 points, A, B, and C. Please tell me their address. Where do they live on the grid? Remember, you start counting from 0. You count left or right first, then up or down. So I'm going to put bigger colored dots because it's a little easier for you guys to see. James, would you like to tell me the address of A? -5, -4. Is there anybody that cannot understand why it is -5 and -4? Now I'm talking to you like you have never seen this before. I know that you have. But I also know you have seen adding and subtracting before. So I am going to continue to speak to you as if you have never seen this before. Okay? Who would like to do the blue one? Karina.
It's
3, 5. You start at 0. You do your left and right first. So since it was positive 3, and then we go up 5. Who would like to do the black one? Connor. 2, -5. Can everybody read this? Great. Now you must reverse what you just did. You are going to put a star. That's a bad star. A star at 3, 0. You are going to put a circle at 2, 4. And you are going to put a square at 0, -3. Go. My pen is hovering at the starting point. Somebody tell me where I put my star. No, Karina, you already got to do one. Yes, that means you can't do one. So direct my purple dot to that point, Ashley. Go left, how far? 3. 1, 2, 3. Then what? I put the star. I don't have to go up and down. Why? Because it's already at 0. Does everyone have a star there? Good. Who would like to tell me where I am putting my red circle? I go right 2, and then up 4. 1, 2, 3, 4. Does everyone have a red circle up there? Excellent. And James, since you are so happy, where do I put my blue square? Down 3. I don't have to go left and right. I thought I said I went left and right first. But it's 0 left and right, so I just go straight down 3.
blue square.
Everybody good? Okay. Now you guys are smart kids. How many variables are there on this grid?
2.
The grid has 2 variables. What are they?
1
and y. What else have we discussed that have two variables? We talked about it yesterday. Karina? The graphs we made yesterday, we didn't make any graphs yesterday. The charts that we made yesterday, right? Relations have two variables. What are they? Independent variable and dependent variable, which I also called input and output. Yes? So you guys are smart kids. If this graph thing has two variables, and you can make an equation that has two variables, what does that mean you can do with every equation? You can put it on a graph. Okay? Okay. So what I have here is I have n and 2n plus 1, don't I? Right? Which one of those is my input? Which one do I decide to start off with? N or 2n plus 1? N. Because we all remember it is IV and then math to get the dv, yeah? Right? So IV must be my input, correct? Because that's the thing I'm going to do math to. So I have n and I have 2n plus 1. Which of those must be my input?
2 plus 1. 2n.
My input is my independent variable. Which of those is independent? The first one, the n. Because this is math being performed upon the n, yes? So, our input is n, so that's our IV, and we always put that on the x-axis. So this side is our n. Where are we going to put that on our graph? On the x-axis. So this must be our output, correct? How do I find that output? I do the math. N is 1. This is 2n plus 1, correct? So what do I do to get 3? 2, what is n? 1 plus 1. What's 2 times 1 plus 1? 3. Everybody cool? What do I do to get 5? 2 times 2 plus 1 to get 5. Now please understand, one of those is the output. One of them is what we call the relation, which gets us the output. Which is the output? Is it the 5 or is it the 2 times 2 plus 1? It's the 5. The 2 times 2 plus 1 is the relation. Do you understand?
Yes.
This is the relation. It's the math. This is the output. It's the result. Okay? Now, I have an x that gives me a y. What does that mean I can do on my graph? I can place it. Now look at my graph. 1, 3. Here's 0, 0. Where do I go to put 1, 3? Over 1, up 3. Now look closely. Is 3 actually on this graph? No, because it goes 2, 4, 6, 8. So I got to put it in the middle there, don't I? 2, 5. 2, 5. 3, 7. 4, 9. 5, 11. What do you notice?
It's a line.
It makes a straight line. Right? Now, what can I do with those dots? I can connect them. Why?
Because it's a straight line.
Because they're all related.
Because they are all related to n. Can I put a fraction in for n? Yes or no?
Yes.
Yes, let's try it. N equals 1/2. So it's 2 times what? 1/2 plus 1. What's 2 times a half? 1. What's 1 plus 1? 2. So when I go to a half up, I'm at 2. Does everyone see how it works? Okay? You guys do this. Which is x, which is y? Well, this is a chart. This is a graph. I'll get to that in a second. Just do the graph. What is my input? 0, 1, 2, 3. What is my output? 2, 5, 8, and 11. So this gives me one spot on the graph, yes? What is that spot? 0, 2. What is this spot? 1, 5. What is this spot? 2, 8. And this spot? Great. Now, let's put them on the graph. 0, 2. Everyone cool?
Yep.
1, 5. Everyone cool? 2, 8. 3, 11. Everyone good? Now, toughest question. Is it a linear relation?
Yes.
Why? Because it makes a straight line. That's what everybody says. I don't see a line, I see a bunch of dots. I have to put the line. Am I allowed to put the line, Ashley? Take a guess.
Yes.
You say yes. Does anybody say no?
Yes. Sometimes you can sometimes you can beat the line because it's sometimes it's going different.
I put the line here. Why?
Because it's a straight line.
Because they're all related to n.
Because I had an equation. I knew what I did, right? Do you know what you did here? No, you don't. You have no idea what is happening between 0 and 1, do you? Could this graph, could it do this? You only have this point and this point. Do you have any idea what's happening in between? No. So the first question is, can you connect the dots?
Yes.
You cannot connect because you don't know what's happening. But does that stop it from being a linear relation? No. Because how far this way did we go? 1. How far up did we go? 2. Right? Did we go up 2? Did we go up 2?
Oh no, 3.
Good. How far did we go this way? How far up? How far this way? How far up? How far this way? How far up? How far this way? How far up? So it is still a linear relation because it makes a straight line. But you cannot connect the dots. Do you understand the difference? You don't know what's happening, but since it follows that way 1 up 3, it follows that pattern, it's linear. Now, does the pattern have to be 1 and 3?
No.
Of course not. It can go over 7 and up 2. But if it keeps doing that over and over again, it's a linear relation. Whether you connect the dots or not depends on what the information is. Okay? And I'm going to show you what I mean by that right now. So, a photographer charges $40 for a sitting fee and $20 per sheet. The charges are shown in the tables and in the graph. All right? So first thing, what's the first thing we need to decide if we're going to graph this thing? We have to decide on variables, don't we? So we need, well, it's not going to be X and Y because we know that we have sheets and money, right? So we got to decide, yeah, that's right, exactly, cost and sheets, right? We got to decide which goes where, right? So we need the IV and the DV. What is the independent? First of all, what are the two things we're counting? Our variables are the two things that can change. They are cost, because depending, right? And the prints, right? Sorry, not the prints, the sheets. Because Karina might order 10 sheets, Ashley might only order 2. So those are changeable values, aren't they? Now, which is the independent variable?
Cost.
The sitting fee never changes. It's $40.
Yeah, that's what is that what
No. The sitting fee is not a variable at all. It's always $40.
Is the sheet.
So, we've already said cost and sheets are the variables. Which one is independent?
Sheet.
Why?
Because
Because cost changes depending on sheets. If Tasha orders 1 sheet and Zach orders 20, who's going to pay more? Zach. Why? Because he ordered 20 sheets, so cost went up. Every time the sheets changes, what happens to cost?
It adds 40.
It goes up. So our independent variable must be sheets, yes?
Yes.
And our dependent variable must be cost, correct?
Yes.
Well, if our independent variable is sheets, is that going to be X or Y? X. And this is going to be Y, correct?
Yes.
So on our chart, which goes on the left? What's first, X or Y? X. So these are our sheets. And they're on the X-axis. Right? What is the fewest number of sheets I can have? 0. I don't like any pictures you took. I'm not going to order any.
But you still have to pay for
What's the next number of sheets I can order? One. Can I order a half sheet? No. Can you go to Safeway and say, I'd like half a can of San Pellegrino, please? Glug, glug, glug. Here, can I have half my money back? Can I? No. Can you go to 7-Eleven and order a half bag of chips?
I mean, they already come in half bags.
You know what I mean. You can't, can you? What's next? 2. What's next? 3. Is there a limit?
Eventually.
Obviously there is. Do we know what that limit is? No. So we're going to put S for sheets. Some number of sheets. Agreed?
Yeah.
Great. Now, over here is cost, correct? So, if I don't order any sheets, how much do I pay this dude? $40. Because he's charging me to take my picture, to decide.
Oh.
That's the sitting fee. Cool? If I order one sheet, have I sat for him? So I have to pay the 40 plus 20. Correct? Everyone agree? How many 20s? One of them. What if I order 2 sheets? 20 times 2. 3 sheets. S sheets.
40 plus 20 plus, times X.
20S. Done. Got it?
Yes.
Great. Now graph it. Is this something we can put on a graph?
Yes.
Not yet. What do we got to do? We got to do the math. What is it? 60. What's this one?
80.
What's this one?
100.
100. Now can we graph it?
Yes.
What are the 3 points that we have on the graph?
60.
No. 4 points that we have on the graph. Where do I find the numbers that tell me how to graph it? When there's 0 sheets, that's an X. What's the Y?
The cost.
Which is 40. So I've got 0, 40. What's the next point? 160. What's the next point? 280. What's the third point? Fourth point? 3, 100. Now let's graph it. This is not set up, is it? Who's in charge? You are. I'm going to say there is 1. Which means what's this?
2.
Which means what's this? 3. Please notice I use 2 squares, but it's only 1 in value. Does everyone see that?
Yes.
Great. Now going up and down. Can I do it the same scale? No. Because then it would be $1 would be here. I can't do that, can I? I need these guys to be $20 each, don't I?
Yes.
So that makes this first one 40, correct?
Correct.
So 0, 40. Cool? 1 is how much? 160. So I go out 1, 20, 40, 60. Cool?
Yeah.
2, 20, 40, 60, 80. 3, 20, 40, 60, 80, 100. Does everyone agree?
Yeah.
Now, the $1 million question. Do I connect the dots?
Yes, because you did the math. Because you know what's going on. How easy it is. I answered that too.
Yeah, I understand. You answered the question. Do Did you think about it? The X's are my inputs, yes?
Yeah.
Okay. How much does this guy charge me for half a sheet?
40.
Can't get half a sheet. He only sells in full sheets. So is there an output for anywhere in here?
No.
No. So can I have a line there?
No.
No, because there's no output. So this is not a connected dot.
So
What is different between this and 2n plus 1?
because
I do not indeed. I should, but that would require her to attend. No. Okay, bye. So, what is different between this chart, because James said, we did the math, we should connect the dots, and this chart, where we did the math and connected the dots?
because that one can have half, the other one can't.
This is not real life, is it? This is just numbers. Fractions exist in math, don't they?
Yeah.
Do they always?
You're a little bit more folks. Sorry for the interruption. Just a few quick reminders for you.
So,
Day, so next block is the last block, and it ends at 11:15.
no
So just wanted to give you an announcement.
fractional
Wait until the long weekend. Grade 12 students, if you didn't get
inputs.
full form was done on Friday, please pick up one of the council.
So,
Your forms are due before May 13th, please.
There can't be outputs for fractions. So, no line. Does everyone understand that?
And both Instagram and Abby Stevens showed its support. One applause, I got my button, you got yours. And we played the last league game today. I think we're ranked number 1. Let's get excited about that. And here in the third floor, let's get excited about that. And they played, the kickoff is at 11:30. Late, they need you to remind to come to the council center right after dismissal and get some pizza. Pre-game pizza! All right, remind applicants to pick up the camp and field trip forms today. And you guys have a fantastic day. Again, tomorrow is a non-instructional day, so it's Monday, so we'll see you on Tuesday.
The outputs make a straight line.
Okay.
We connect only if fraction inputs are allowed. Does everyone understand?
It has to be input and output to connected.
The inputs have to allow for fractions.
Yeah,
If they do, you connect the line.
no, that's what I'm saying.
And I'm repeating it.
So say you could buy half of pears or fruit,
Yes.
and then the other.
Yes. We will finish this tomorrow, obviously. You have no homework tonight.
Tomorrow we don't have class.
Omar, you really want to make that joke for the 100,000th time? The next time you're in class, we'll finish this joke.
Tomorrow.
The next time you have class,